Stanford University.
Welcome to Lecture 3, CS193P. Today we're going to cover a few different things, particularly how you're going to create your own custom classes, how you're going to allocate and manage your memory, Autorelease, which is a memory management tool that you'll get to know very well over the next couple months, and something called properties. So let's get started. First, some announcements. Assignment 1A and 1B are due tomorrow. So hopefully you've all started on it. Hopefully you all have your development environment working perfectly. You have to submit by tomorrow evening, 11:59 p.m. Don't submit the build folder. If you do, it's probably not that big a deal, right? But if you want to remove it, it'll make your submission smaller, and we're going to rebuild it anyway. So delete your build folder, then do your submission. Instructions for submitting are all in the assignment. Is that right? Yeah. OK, if you have any problems in the next day and a half, or after that, any problems, email us at cs193p@Stanford. Yeah?
The clean all, that was just cleaning all the targets, right?
Right. So the question is, yeah, clean all cleans the targets. It doesn't remove the build directory. And I dare say this, sometimes you're better off removing your build directory than cleaning with Xcode. And I'm not sure why. I don't know what the circumstances are. But if you ever find that your assignment is acting kind of weird and you keep cleaning it, try removing the build directory. Little tip. Also, with the email address, I'd like to encourage people, if you have questions regarding the assignment, regarding anything having to do with the class, email this address rather than us individually. There's several of us on this email list, so we'll get to your answer a lot faster, and I'd encourage you to start there. The next assignment, assignments 2A and 2B, are due next Wednesday at 11:59. 2A is a continuation of what you did for this assignment. We're going to add a lot of the pieces that we talk about today. All of the pieces that we talk about today are in next week's assignment. And 2B, also due next Wednesday, is a start for the Hello Poly assignment, where you're going to build a polygon class that knows how to draw itself at different number of sides. We're going to cover that information. Actually, that might be wrong. It may not be Thursday. It may be next Tuesday when we cover drawing. In any case, the information will be there in the next couple of days, next week. And the assignment descriptions are pretty extensive, especially the 2A one. It's like 4 pages and describes all the things you need to do. So again, email us if you have any questions. Now, so enrollments have gone out. Everybody, if you made it into the class, should have gotten your email already. I'd like to encourage enrolled students to come to this class. We're doing something new with the iTunes U lectures this year with the videos. We're getting them closed captioned, which takes a little bit longer before they get processed and posted to the website. So I'd really like students to not rely on those, enrolled students, because you're going to miss pieces that are important for your assignments. So please come to this class. And yeah, we'll get the videos up. It just might take a little bit longer. Great for those of you online. And office hour updates. So Paul and David both have office hours now. Paul is on Thursday from 2 to 4 in Gates B26B. And David on Mondays from 4 to 6 p.m. in Gates 360. So let's get started. Any questions first about the assignments from last week, from this week, before we move on? No? Has everybody started the assignments? Show of hands. How many people? What, 3 people? OK, there we go. Today we're going to talk about, so like I said, creating a custom class, a class that you define. And we'll talk about some memory management, the life of the object, so when you can expect an object to be allocated and released, or deallocated. And then we'll get into different ways of accessing variables on those objects, using properties and using setters and getters. So let's start with custom classes. The way you design a class, the process you go through, we're going to start with defining what the class is. And today we're going to go through defining a person class. So first you decide, as in all object-oriented programming, decide what you want to create, what it represents, what data it holds, what the behaviors are, but what that object is. Then you're going to determine what the superclass is. In general, if you're not subclassing from some other more complex object in Cocoa, NSObject is the object you're going to subclass from. It's the base object in all Objective-C, as we discussed last week. You're going to decide what what properties that it has. So today we're going to say it has a person has a name, it has an age, and it has a behavior, which is whether they can vote or not. It's actually a property, and we'll see that in a little bit. And we're going to, this is the behavior. So the behavior is going to be to cast a ballot. So the person is going to vote, and we're going to check whether he's allowed to vote. We're going to use his name and his age to do so. So when you create a class, there's two files that will get created. If you go into Xcode and say new file, it'll ask you what kind of object you want to create. Let's say you just create a base object. It's going to create a .h file and a .m file. The .h file, which you're probably familiar with right now already from C and from C++, from Java, is your header file. It contains the declaration of the class, the structure of the class, the blueprint. And the .m file is the implementation file. It contains the guts for how things work. And a way I've heard it described to me is if you think of why .m, well, implementation, m, .c was taken, and .o means something else. So .m is your implementation file. So let's first look at the header file. So in our header file, we're going to start with the @interface keywords, and @end is down at the bottom. That's how you define the scope of your class. And @interface is followed by the name of the class itself. So in this case, person. Person is a subclass of NSObject. So we use a colon to define, to say that the superclass is about to follow, and it's NSObject. NSObject comes from the foundation set of classes. So we're going to import the foundation.h. And I believe we mentioned this last week, but we're using #import here instead of #include. And the reason for that is kind of a nicety of Objective-C, where #import automatically does the detection to make sure that you're not including the same header file twice. You may have run into problems in the past where you include some header file, and that header file includes some other header file, which includes the original header file. And you get this, this cross-compilation, this like infinite loop of compilation. The compiler tells you off, says you shouldn't do that. And so oftentimes you'll see there's, at the top of header files it says, if not defined, some constant, and then else, and just to prevent that it doesn't get included twice. #import does this for us. So we're going to #import foundation.h, which will bring in the NSObject class for us to subclass from. We're going to use curly braces to specify the ivars. And here are the two ivars we're going to have. So an NS string, which is the name, and an integer, which is the age. Below that, but within the @end scope, we're going to have our method declarations. And in this case, we're going to have accessors for name and age, so name and set name, age and set age. We're going to have an accessor for can legally vote, which is going to return a Boolean, and a cast ballot method, which is going to do the voting itself. One thing you should notice with these with the setters and getters, there's a pretty standard convention here, which is that your getter will always return the type of the object that you're returning, or the type of the variable you're returning. And it starts with a lowercase letter. In this case, name. In the second case, it's age. And in the setter case, you return void, because you're setting a value. You're not getting anything back. But you start the method name with set, followed by the uppercase version of whatever instance, whatever variable you're going to set. And then colon, the type of the variable, and the name of the variable. So that's the header file. Let's look at the implementation file now. Our implementation file is going to include setter and getter methods and the action methods that we defined earlier, which is the cast ballot. So let's look at this. We're going to #import. Everybody turn off your cell phones. #import person.h, the header for the class, the defining structure for the class. And then we're going to use @implementation followed by the class name. And @end ends the scope. You'll notice in Objective-C there's a lot of these identifiers that start with followed by something, @interface, @implementation, @class, @selector. There's a few of these. In fact, we even use the %@ for formatting strings. The @ implementation in this case is just another keyword to Objective-C to say this is where we're defining the methods in our class. And let's start with age. So the age case is pretty simple. We know our class has a variable named age, an instance variable named age. So to implement our getter for age, we're going to return an integer named age, and we're just going to return it. And in the setter, we take an integer named value, and we assign the value to the age. Right? Easy enough. Any questions on this so far? Okay, pretty basic stuff. Inside your implementation file, if you need to call other methods in your implementation file, you use self. And I'll show you in this case, here are two functions we're going to implement right now. Can legally vote, which is going to call self age and check if the value is greater than or equal to 18. Now, you could also check the variable, the instance variable directly. But the convention in general is just for encapsulating the setters and getters of each of the properties. Where you don't need to access that instance variable, don't. Call the setters and the getters. It helps you localize some of the code to those places when you need to. If you need any more, I don't know, complex function happening at that time. So in this case, we're going to call self age, check if it's greater than or equal to 18. And in cast ballot, similarly, we're going to call self can legally vote. Right? And we know that can legally vote returns a Boolean. So if it's true, we're going to vote. And if it's not true, we'll just log and say, hey, I'm under 18. I'm not allowed to vote. So superclass methods. So if you override a method that is implemented in the superclass, you have a way of calling that superclass method, and that's using the keyword super. So let's say we have another method called do something. Yeah?
So you don't need to use self when you're calling an instance variable?
The question is, do you need to use self when you're calling an instance variable? You don't. You don't need to. The convention is to use those setters and getters if you don't directly need to access the variable. So I mean, there's always exceptions. There's always cases where you will need to access the instance variable directly. But if you don't, if you're just getting a variable or setting it, go through your setters and getters.
Can't you just call the function without using self?
So the question is, can you call the function without using self? And the answer is no, not in Objective-C. You need the self in order for it to go through the accessor methods. If you don't use self, it's going to get the actual memory for the variable. Does that make sense?
Yep.
Yeah. OK, so a little more about super here. If our superclass has this method called do something, and we want to override that behavior in our subclass, we will call super do something, and then we'll do whatever we need to do. And again, depending on your implementation, you may want to do something before you, the ambiguity of the word do something. You may want to perform your actions before you call the superclass, but that's up to you to define based on your implementation. Yeah?
So do you need something above it? Like I know in Java you need add override to actually override the superclass method.
So question is, do you need to specify, that's a good question, do you need to specify that it's an override of a superclass method? The answer is no. You implement it like any other method, and as long as you know that it exists, and you should know that it exists, or it would be in the header file, and just call super on it. So, other questions? OK, I want to talk about object lifecycle. So what does this mean? Well, this is, when is an object created and when is it destroyed? Yes?
So when you get it from superclass, if there's nested superclasses, does it just take the most recent one?
So the question is, if there's nested superclasses, will it just take the one above it? And the answer is yes. So if you have, let's say you have something that, something that inherits from NSObject, and something inherits from that, and something inherits from that. If this guy calls super, it will call the implementation on its superclass. If its superclass doesn't implement that method, it's going to go straight to the one above it. Because it actually does implement, well, no, it doesn't implement that method, but it'll kind of go up the chain until it finds one. Does that make sense? OK. Okay, so let's get into how do we create objects, how do we manage that memory, and how do we destroy objects? When do those things happen? So first thing we're going to look at is object creation. When you allocate an object in Cocoa, what you generally do is you do two things. You do an allocate and you do an initialize. And the allocate finds a block, it will create a block of memory for the class that you're calling it on, and the init will set up the memory so that it's ready to go. So let's take a look at this. Alloc is a class method. So in the case of person, I would call person alloc. And what that does is it creates the block of memory that's big enough to hold the person and all of the memory that is required by NSObject. And then we're going to call init. And init is going to do whatever we tell it to in our implementation of init, which could override some variables, it could set some initialization. NSObject's init actually goes through and clears all of the memory for you. So everything's zeroed, which makes things pretty convenient. Remember we talked about last week that if you message nil, then it does nothing. It's pretty convenient that NSObject clears all that stuff for you, because then your object is in this default state. You don't have to worry about memory being uninitialized and stuff like that. So here's an example of allocating an init. First thing we're going to do is we're going to declare our object instance up at the top. So it's a person star. We're going to assign nil to it just so it's clear. And then we're going to allocate an init. You notice here that it's two method calls you're making. One on the class, which is the alloc, and then one on, we're going to call the instance that comes back from alloc, we're going to call it with init. Inside of our implementation, let's override that and set some default values. So we're going to set up this init method that returns ID, which we talked about last week, which basically returns the initialized version of whatever object you're creating. And what we're going to do here is, first we're going to check, we're going to call super init. So we need to make sure that we call NSObject's init call so that everything gets cleared and set up properly. And we're going to assign it back to self. Okay, and I'll explain that in a second. But down at the bottom of init, we're going to return self. So the result of any init call should be the object that you're initializing. Now the reason we do this may seem a little peculiar. You just allocated the memory. Why do you need to assign something to self? In some very rare cases, init will actually change the instance of the object that it returns to you. So let's say you have some collection that wants to check to make sure it's a unique object. There's rare cases, and I wouldn't worry about it in this class. We're not going to hit it. There's rare cases where the init call may go find some other object and return that to you. So just as a convention, we're going to always follow that we're going to return the result of super init to self, assign it to self. And that's what we're going to return down below. Does that make sense? This is usually a little dicey, but that's the convention to follow. Let's go with that. And inside, so we make sure that self actually was a value, right? So the result of super init is going to set self. We want to make sure that self is not nil. That's why we have an if statement up here. And then we're going to go and start initializing the values. So age, we're going to start with 0. And let's say all of our people are going to be named Bob as the default name. So that's that. Questions? Okay. Yeah?
So you said we're going to do that if statement there to check to make sure that self isn't nil.
Right.
What if self is nil? Do you have like an else there to handle that case?
So yeah, the question is, what if self is nil in this case? Probably something went wrong. Something went pretty wrong if that's the case. Maybe the memory couldn't be initialized. Probably something bad is going to happen after that. But I've never run into it. I've never had null return from init. Do you know when that might actually happen? No. I think what will happen is, so let's actually follow this through. If self comes back as nil because something failed here, you're going to get a nil object back from your init, and whatever code called your alloc init is going to be nil, and then you could just continue on and should be fine. But I don't know why that would return nil. Again, maybe because ran out of memory, in which case you have other problems, or yeah. So, so another convention in Objective-C and Cocoa is that you may have multiple init methods on an object. Okay, init is always the basic one, but what happens is they may get more complex. You may want to initialize with a string and initialize with an age, and in this case, we're going to have both. So the implementation of these, the simple ones always call into the more complex ones. So init, our base init will call into init with name with a default value, which is no name. And our init with name would call into init with name age with the default values. So what we have is we have something called a designated initializer, which is the init with name and age. And generally, when a subclass wants to override the full behavior of its superclass, it would override the designated initializer. And then this guy, init with name, could go in and it could set the name and it can set the age. And when it calls it its super, since the super doesn't have a designated initializer, it would call init. Does that make sense? Okay. So when you see these cases where you have, or when you're creating a class that has multiple init methods, you want to make sure that your simpler ones call into your more complex ones. And okay, so finishing up with an object. So we've allocated and we've initialized an object up at the top. We got him back, person. We're going to set his name. I'm going to set it to Jimmy Jones, an age of 32. Then we're going to vote. We're going to cast the ballot and potentially do something else. What do we do then? Well, we have to release the memory or we leak. So what are we going to do here? Well, let's take a look at our options. In C, you're familiar with malloc and free. So when you malloc an object, when you malloc memory, it creates the memory, and when you call free, it deletes that memory. You're done with it. You try to do anything with that memory, it's invalid. In Objective-C, we also have two methods, which are alloc and dealloc. But there's something different about the use of these. The calls must be balanced. So if you, like in the C case, if you called free too many times, you're going to crash. It'll probably tell you that the memory was already freed, or it may just crash and not tell you anything. It's the same thing in Objective-C, but the difference here is you're never going to call dealloc directly. And I'll explain that in a sec. Except for one case, you never call dealloc directly. Instead, what you have is something called reference counting. So NSObject takes care of counting the number of times that those objects are being used. And it does it with two methods, one called retain and one called release. So every object has a count, again defined by NSObject. And as long as that object retain count is greater than 0, the object will not get dealloced. And as soon as the retain count goes to 0, the memory is going to go away. So by default, alloc and copy always create objects with a retain count of 1. Retain increments the retain count by 1. Release subtracts 1 from the retain count. And when the retain count goes to 0, so you've called release enough times to match the total number of retain, alloc, and copies. When the retain count goes to 0, dealloc is going to be called for you automatically. And once you're in dealloc, that means your memory is about to go away. There's no way to turn back. So, well, let's look at an example here. So in this case, let's say we alloc and initialize person. We're going to set the name to Jimmy Jones, et cetera, et cetera. When we're done with it, we're going to call release. And in this case, the alloc increased the count by 1. It created an object with a count of 1. And the release down at the bottom takes the retain count down to 0. So again, as soon as it goes to 0, the memory goes away. So our method, our function's dealloc, our class's dealloc will get called. I'll show you that in a sec. But here's a, yes?
In the main function, when I set up my Xcode, instead of having release, it has drain instead. What's the difference?
OK, so the question is, when you set up your Xcode, it says drain instead of release. So that's on the auto-release pool. We'll talk about auto release a little bit later, and it'll make a little more sense then.
What happens if you have like two objects that are pointing to each other, so they both have positive reference count, but nothing else?
Right.
to get to that?
So the question is, if you have two objects, let's say you're holding on to two objects, and each object has a reference to each other, those retain counts, they won't go to 0 unless one of the objects gives up the other one.
So will that be a leak if nothing else can get to them at the end of your program?
If nothing else can get to them, yeah, you're going to leak. So, did you have a question too?
No.
Okay. So let's look at reference counting with retain and release in here. So when I allocate the object, it's going to have a retain count of 1. Then I call retain on that object. It's going to go up to 2. I then call release. Retain count goes to 1. And if I call release one more time, the retain count goes to 0, and we're dealloced. So, and I'll show you overriding dealloc in a moment. So, okay, what happens if you call release enough times that your class is deallocated, and then you try to message that object? Well, you actually have bad memory. So after, in this case, again, we allocate, count as 1, we release, count as 0. At this point, person is an undefined block of memory. So if you try to do something, it's going to crash. So one convention is once you release something, set your local instance of that variable to nil. And then if you try to do something on it, it's not going to do anything. Now, if you've written code such that it's going to try to do something after you released it, it may be doing, you know, this is probably the case where they're not in the same function. But in general, you know, you want to make sure that you match your retains and releases in such a way that you know what objects you have. So let's look at the dealloc method. If you remember, well, if we look at our class, so we had an age and we had a name. When I deallocate that, I'm going to want to release the name. And I'll talk about the name itself more in a moment because we have to look at the setter for it. But when we're done with a dealloc of our own class, we need to make sure that we call super. And this is the one time when you're actually going to call dealloc, is only when you're calling super. So we were just called to say that our memory is going away. We do whatever cleanup we need to do, and then we go and tell our super class that it should clean up as well. So let's look. So the object lifecycle, once again, starts with a retain count of 1. It increases and it decreases with retain and release. And when retain count goes to 0, your dealloc is called. You never call dealloc directly unless you're calling it for super inside of your dealloc call. And you only deal with alloc, copy, retain, and release for memory management. So now let's talk about the name case, right? So in this case, we have an object. Our person object owns the name object, the NS string. It wants to keep a reference to it. So let's go and implement the name and set name methods. So back to our implementation file. The name, the getter, is pretty simple, right? We're just going to return the instance variable to whoever called us. The set is a little more complex. Because we have this object ownership case, what we want to do is check to see if the value that's passed in is the same as the one that we already have. If it's not, then we go ahead and we release the old object so that its retain count gets decremented. And then we're going to retain the new object that comes in and assign it to our local variable. So, you know, one question I always hear is, well, why do you have to do this if statement? The if statement that says, you know, why not just go ahead and do it? Well, the case is, let's say somebody passes in a new name that is the same object as the old name, and you're the only one that's holding a reference to it. Your person object is the only one holding a reference to it. If you went ahead without this if statement, you're going to release the old value, which is your value, which is going to cause that dealloc method to be called immediately. And again, there's no turning back. And then you're going to go and try and retain it, but you've already deallocated the memory. So we check to see that, you know, the way to do this is you check to see that the value coming in is not the same as the one you already have. Then you go and release the old one, and then take the new one with a retain count. Yeah?
Is there a way to access the retain count?
There is. The question is there a way to access the retain count? And this NS object has a method called retain count. and it returns an integer. So, yeah.
Why are you simply changing the name?
I'm sorry.
Why are you simply doing names equal to name?
So the question is, why are you not simply saying name equals new name? Well, what we want to do is we want to keep a reference to it. It could be that somebody passed us. In general, you want to match your retain and release counts. So let's say somebody created a name, an NS string, and passed it to us, and then it thought that it was done with it. So it deallocates the memory. The next time that person tries to access the name, it's going to be bogus because it got deallocated. And so the way to maintain that is you increase the retain count so that that object that got passed into you doesn't get released until you say it should. So, that make sense? Okay. So another way this is sometimes done is copy. So instead of retain, you may want to copy it. And what that'll do is it'll make sure that somebody else, if somebody wants to go and change the name, again, there's this NS string and NS mutable string, but let's say somebody passes in NS mutable string that they can change. If somebody goes and does anything with that, if you copy it, you're going to keep the name that was passed into you and it won't change from under you. So oftentimes you'll see string properties are set up as copies rather than retains. So, yeah.
So basically, if you pass everything by reference.
Mm-hmm. The question is, generally, yeah, you always pass everything by reference. In fact, in Objective-C, I find since everything is a pointer to an object, you don't ever have to worry about pointers and static instances. Everything's always a pointer. So. Okay, so now let's release instance variables. Let's take a look at our dealloc. Well, because we took in our setter here, again, we took a reference to it by calling retain. We need to, in our dealloc, make sure that we release it. And how we're going to do that is by calling name release. And what that will do is, let's say we're the only one holding on to a reference. Name will go to 0. The object will go to 0 at that point, and it will get dealloced. And then, of course, we always call super dealloc. So, yes?
So, say the object has a reference to it, but say you still have a reference to it, like it's still on the stack or something, you still have a stack pointer to it or something, do you still need to release it on there to actually get rid of the object completely?
So, question is, if somebody else has a reference to it, do you need to release it again to get rid of it? Is that right?
If you pass it in, say if you've already alloced the string and then you pass that alloced string into an object,
right,
and then it copies it, you still need to release the reference you have that you passed in.
Right. So every object that in this case we're retaining and releasing. We're maintaining our own allocation. Whoever passes that object in itself is responsible for releasing to match its number of retains. So yeah, the question, more specifically, if somebody else allocates that object, passes it into us, we do whatever we do, we're done with it, we've retained and released it. Our count, as far as we're concerned, we're a net 0. This guy over here still needs to release in order for that object to be deallocated. So, yes?
If someone outside the class releases it twice, does it destroy your copy?
Yes. If somebody else releases that twice and they only retained it once, then yeah, your counts are going to get off. So they really need to be matched. You'll hit bugs like that. Those bugs kind of suck, but the tools are actually pretty good at helping you catch that stuff. So one thing I tend to do and I tend to evangelize a lot is try and match your retain and releases or your alloc and releases in a pretty fixed scope, right? So if you're creating something that's going to get passed in and you're done with it, that's where you should be releasing it. If you're creating something that gets retained as a setter, then in your dealloc, make sure that that gets released as well. Yeah.
So if you have a setter method that's getting like an object, not like an int or something, you pretty much always want to retain it. Is there ever a case where you wouldn't retain it?
So the question is, if you have an object that takes another object, do you always want to retain that object? The answer is no. And there's a specific case called delegates, which we'll deal with later in the term, where you generally do not want to. And it's really to take care of this case where if you know that somebody's going to own you, you don't want to own them if you need to access them, because you really don't want to you don't want to have this double retain cycle. So yeah, there are cases where you don't want to retain the object, and yeah, we'll look at that with properties in a little bit. Yes.
And in the case of the int age,
Yes.
we didn't do this because that was not an object.
So in the case of the age integer, yeah, because it's not an NSObject subclass, it's just an integer, we don't have to retain. So yeah.
So if there is a case that we have a circular reference, how do you access the other object? Let's say there is a parent-child relationship.
Right.
And the parent needs to access the child, and the child needs to access the parent.
So,
how do you do that?
well, this is a case that actually exemplifies the you don't want to retain. So let's say the question is, if you have a parent-child relationship, how do the two access each other? Well, in general, the way I've seen it implemented is the parent creates the child, so it takes a retain count, and it keeps it in some kind of array, right? So, or maybe there's only one. It keeps it as a child, and it assigns itself as the parent, and it's maybe there's a set parent, and the set parent is a special case where it will not retain. That's the case where it can keep a reference to it as long as it can count on the parent maintaining its memory management. So, yeah, it's an implementation detail, but it's that's the way you would do those relationships. So, any other questions before I move on? Yeah.
So I guess your best bet then is if you do want to retain something inside of an object, then is to delete the referencing that you actually have, then let the object retain the full, and then when you deallocate, then have that do all the memory management.
Sorry, say that again. So if you, when you're done with an object.
So I guess if you're not going to use it besides passing it to the object, then it's better just to release it right then and let the object handle the rest of the releasing then.
Absolutely. So question is, well, what's the best way to do this? If you are passing in an object that you've created to another object, the best way to do it is if you're done with that object and all you did was create it so that you can pass it into another object, you delete it, you release it right away. And because the other object retained it, it's going to maintain its own memory, and it'll go away when the other object is done with it. So, okay. Now there's another case where the retain and release counts will go up and down, and this is auto release. And this is really useful in a lot of cases. I'll show you a few where you don't want to worry about releasing things right away. And why would you want to do that? Well, let's look at let's say we have this method called full name, okay? And it goes and it takes the first name and the last name as instance variables in whatever class you're implementing, and it creates a new string and returns it to the caller. Well, who's responsible for releasing that? And how does the caller know that he's supposed to release the result when he gets it? There's a few ways you can think about this. If you did this, and let's say the caller of this method doesn't know any better. He just calls it. If you just do this, your memory is going to get leaked. Okay? Now, if you release the memory before you return the object, then you're returning garbage memory. So this is wrong because you're releasing too early. So the third option here is something called auto-release. Now, what auto-release does is it actually, instead of decreasing the retain count immediately, it puts it on a stack and says, let's release this later. And I'll talk about how that works in a moment. But what happens here is the caller gets an object that will be, for now, let's just remember, it's going to be released later. And the caller of this can do what he wants with it. He can retain it if he wants. He can, copy it, whatever he needs to do. Okay, so again, auto-release flags the object such that it will be called with release at some point in the future. It lets you make sure that your class is doing the right, matching of retain and release. Right? Again, if we look at this, our alloc is matched by an auto-release, so +1, -1 as far as we're concerned. It makes it really convenient to manage memory, and it's great for these caller methods when something needs to create an object and return it without worrying about whoever calls it, what they're going to do with it. Now, you may see some cases where a method actually allocates but does not auto-release, the convention is always to say alloc, copy, or new as the prefix for that method. So if you call a method, let's say UI kit or foundation, if you call a method that begins with alloc, copy, or new, right, and we've already seen alloc, that's going to return a non-auto-released instance of an object. So you're responsible for decreasing the retain count. And I would encourage you in your own code too. Oh, here's an example. So in NSString, when you call alloc and init, because this thing started with alloc, it's allocated, so you have to release that memory. All other objects release auto-released objects. And if you find, I'm very doubtful you'll find a case in UIKit or Foundation at this point that doesn't do this properly. But I would encourage you in your method naming to do the same thing. So if you're creating a method that has to allocate something and return a non-auto-released, prefix it with alloc, copy, or new. But in general, you're going to want to return auto-released versions of objects. So here's the counterexample from Foundation. When you see this, when you see the alloc case, you have to release it. But in the case where you see a function that starts with string, it's pre-auto-released for you. And I think that's what we use in the exercise so far. And this is true. You've seen this. You may have seen this in NS number. Some of them will start with number with int. What else? There's in the UIKit side, there's UI button with type. Those things are all auto-released for you. Again, this is a convention. You should do the same. So, okay, let's look at how this works. So auto-release, when you call auto-release, it adds it to something called an auto-release pool. And you've probably seen auto-release pool when you created a project for the first time. It actually wraps your project in main. It wraps the project with NS auto-release alloc init, and then NS auto-release, that pool it releases afterwards. This is the pool that these objects are getting added into. When the objects are scheduled to be released, basically all the objects in the pool are iterated over and released when that pool goes away. And this is the case where you saw drain. So when you call drain on an auto-release pool, that's telling it to go through all of the objects that it has in its pool and call release on each one by one. Okay. And actually, that's the time when they may be called with dealloc or they may not be called with a dealloc, right? So let's say, let's take the case where I've created an NSString object and I've retained it. Let's say I've retained it 3 times, and one of the times I put it in the auto-release pool. Well, if it's only in the auto-release pool once, the retain count will go down from 3 to 2, and it will not get dealloced. If I create an NSString and I put it in the auto-release pool and nobody else retains it, when the auto-release pool gets drained, that object will get released right then. Does that make sense? And then UIKit automatically creates and releases the auto-release pool, automatically drains the auto-release pool with every run loop, every event. So, well, here's the life cycle. So when you start your application, it starts, you launch the app on the iPhone, it initializes the application, and then it loads the main nib, which is the interface for your application. Then it starts something called a run loop. And what that does is it basically, the application sits there and it's monitoring inputs to say, hey, has the user done anything yet? At the point that they actually do something, then it proceeds to here. So it handles the event. And that event, well, before it does that, it creates this auto-release pool. Now, that event might go through and create a bunch of objects. So let's say here we've created an NSString and we say auto-release. Well, that object goes into the pool. Okay, so then let's say in this same event you're doing a whole bunch of processing before you're done. You create another object. Well, you call auto-release on that object. It goes into the pool. You call auto-release on another object. It goes into the pool. And when you're done that event loop, so when you're done all your processing, that pool gets drained, and each of these objects get called with release. So does that make sense? So when you're done, the event loop is finished. All your auto-release objects will get released. And if the retain counts go to 0, then they will get dealloced. And again, the time frame for this is microseconds. This isn't like several seconds. It's, as soon as you're done adding whatever you're doing, casting a ballot, whatever you're doing. At that moment, that's when it gets called. So if you want to hang on to an object that is auto-released, you can bump the retain count. So again, let's say you create an NS string, which is auto-released because you called NS string with format or something like that. But you want to hold on to that to later. You call retain on it. And that's the case where we assign it to an instance, a setter, right? So when we call setName on that, it's going to retain that object. Then the auto-release happens. The retain count goes back down to 1. It doesn't get dealloced. And then when we deallocate our person object, that's when we're going to decrease the retain count on the name, and then it gets dealloced. Okay. Yeah. Okay, so here's just an example of that. You create it, you get a string, it's auto-released. You want to retain it, you keep it. You call release when you're done with it, and it'll get released when it's ready. Okay, garbage collection. This question often comes up. Is this garbage collection? And the answer is no, this is not garbage collection. There's no garbage collection on the phone, on Objective-C on the phone. There is on the Mac. We're not going to worry about that. But you still have to remember what you're holding on to and release things when you're done with them. So, any questions on the auto-release? It's not the easiest concept. All the memory management stuff tends to trip people up, but you'll get it. It starts to make sense, and then you'll be a big advocate of it, I guarantee. So, all right, let's move on to properties. This is another way of defining instance variables in your app. And more importantly, it's another way of creating setters and getters for you. So you have an object and you want to provide access to different attributes of that object. What you can do is you use properties. They will, you do something called synthesize, which I'll show you in a moment, that will tell the compiler to automatically generate setters and getters for you. It also has keywords for doing things like specifying whether a property is read-only or read-write. And it will allow you to specify in the property declaration whether that memory should be retained, copied, or just assigned, like in the parent-child example. So here's our person object so far, our person class declaration so far. We have the name and set name. We have the age and set age. And we even have this can legally vote, which returns a Boolean. Well, we can take these 5 methods and reduce them down to 3 properties. Right? So we have an integer property, which is age. We have an NS string property, which is name. And that NS string, you have to, when you have an NS object subclass that you're using, when you have an object, you want to specify what the memory management is on that. So in this name case, let's say it's copy. And we have this can legally vote, which has no setter. Right? There's no set can legally vote. That's handled internally in the class. So we tell the property that this is a read-only property. And then the cast ballot down at the bottom. Okay, so how do we, let's look at the implementation now. Well, we've written all this code. I just finished telling you how to do all this. We're going to make it a lot smaller now. Instead of writing the setter and getter for age and the setter and getter for name, instead, we're going to reduce this down to 2 synthesize calls. So we've taken all that code and we've turned it into @synthesize age and @synthesize name. And what that does is it automatically generates the setter and the getter for you based on the memory properties that you set, all the properties you set in the declaration. So read-only versus read-write. Here are some of the settings you can put on a property. Read-only says that it should not generate a setter for you. It only generates the getter. And here are the memory management properties. So assign, retain, and copy. Assign means when it creates the setter, it will not retain the new object. It's not going to release the old object. It's just going to assign it. Retain is going to do what we did earlier, which is release the old object and retain the new. And copy will do the same. It'll release the old object and copy the new. Okay, so property names versus instance variables. Let's say we went and we created this person object, but we're a little more verbose. All right, we made our instance variable name be number of years old. But somebody reviewed our class and they said, well, why are you calling it number of years old? Why don't you just make it age? Well, you've got so many dependencies. Anyway, you can name the property different than the instance variable. Now, the way you tell the compiler to generate the setters and getters for you is when you synthesize, instead of just saying synthesize age semicolon, you say synthesize age equals the name of the instance variable, number of years old. So, all right. So another thing you can do is you can so the synthesizer will generate these getters for setters and getters for you, but you can still implement your own setters and getters. So in this case, we have a synthesize age and a synthesize name. But at some point in the future, we decided that we need to do something a little more complex with the age. So let's say if the age is 16, we want to flag that they need a birthday party or something. In this case, our set age, even though we have the synthesize up above, we can still implement set age. We have to do the manual work of doing the assignment that the automatically generated synthesize would have done for us. But then we can go and do whatever else we need to do below that. So here's a case where the getter method is still synthesized, and our setter is overridden. Yeah?
The name value there is important. Like if you had changed that to something else for that.
Question is this value imported? And I'm pretty sure, I think you can, well, in this case, in the synthesized case, the value doesn't even appear in the header file. You can name this whatever you want as long as you're consistent within your method, right? So. All right, so properties in practice. What you'll find throughout the UIKit and Foundation APIs is that properties is a Objective-C 2.0 thing. It's pretty new, last 2 years, I think. So newer APIs from Apple use properties fairly widely. Older ones do not use it because it wasn't around at that time. And over time, they've been migrating some of the classes to using properties, but they're not all there. UIKit, because it's new, has a lot of properties. Foundation, not so much. And you can do either approach, right? Again, it does a bunch of stuff under the hood for you. If you'd like to be explicit, you're welcome to be explicit. So I think, let's see. Okay, so dot syntax itself. I want to talk a little bit about how does an object use dot syntax on its own object. You need to be conscious as you're doing this, right? So properties and IVARs in some languages, if you said self.age equals age, you're actually accessing the offset into memory of the age instance variable. In this case, you're not. When you say self.age, you're actually calling the setAge method. So here's a case where, let's say I'm going to, I've got some method called do something. If I have this instance variable called name and I have a property called name, if I say name equals Fred, that's going to access the instance variable directly. If I say self.name equals Fred, it's going to call the synthesized self-name method, which will retain this and release the old. So be conscious of when you're using this. And can anybody tell me, let's take a look at this. So setAge takes an integer, and then we call inside of this method self.age equals new age. Can somebody tell me what's going to happen? Yes?
It's an endless loop.
Right. So it's an infinite loop, right? setAge is going to call self.age, which calls setAge, which calls self.age. It's going to keep going forever. It's an infinite loop. And don't do that. That's all I have on properties. Maybe I can do a little example on auto-release. How are we for time? 20 minutes. I can do a little example on properties and auto-release and stuff. Here's some things you can go take a look at if you want to find out more about it. The docs for this stuff is pretty good. It's been around for several years. You'll find in the Memory Management Programming Guide, you'll find two different ones if you go searching for this. One is for iPhone and one is for Mac OS. And most of it's the same, but the Mac OS stuff will talk about garbage collection, which again we do not have on the iPhone. So just to make that clear. All right, let's look at an example. Any questions before I do that? Yeah.
I may have already said this, but what's the difference between minus and the plus? Is that private, public sort of?
Right. So the question is, what's the difference between minus and plus in your method declarations? And the answer is, so minus calls an instance. You call minus. Let me start again. The methods that start with minus, you call on instances of objects. The methods that start with plus, you call on the class name itself, on the class itself. So again, if we look at the alloc init case, all right, let's just look at this really quick. Alloc and init. You'll notice that in the alloc case, this is the class name. Right? So we're actually calling alloc on the class, which says go and allocate the memory. And init is called on the instance of it. So plus is call on the class, init is call on the instance. And yeah?
Is there a difference between that and like static versus non-static in Java or something?
So the question is there a difference between static and non-static in Java? Yeah, go ahead.
So the class methods are pretty similar to static in Java. I actually know more about static in C++, I guess, than Java. In C++, the static is going to be on the class, but that won't have... well, it's pretty similar to static in C++, I guess is what I mean. There's no instance variables associated with the static methods because they're you're messaging the class itself, the object that represents the class. So you can't have variables in there.
So I think basic answer is yes, they're roughly the same. Is that right? So yeah.
So class methods that, so say for like NSArray, how we weren't supposed to use alloc or init.
Right.
Like, so are those auto-released then?
Yeah. So the question is, in the assignment, we used NSArray array with objects instead of NSArray alloc init with objects. We did that because we didn't want to. Well, we weren't going to get into memory allocation until today. But yeah, the answer is, I mean, what's happening there is the array with objects gives you an auto-released array. So that array is going to go on the auto-release pool. Yeah.
And then you mentioned last time that in like an NSArray you need to have nil. Is that necessarily? Because I mean, I didn't put that in mind.
Yeah. So okay, at the end of your, let's say, array with objects method, which is what we use to create the array with a bunch of objects. The nil is just to tell that function that there are no more objects coming, right? So that's the end of the list of objects that you're going to provide to it. If you don't have the nil there, it's going to keep trying to read memory afterwards, and yeah, bad things will happen. So there's another one. There's an NSArray array with object that, by definition, only takes a single object, and then you don't need nil.
But then, so that if it keeps iterating through like a for loop, then, but what if it doesn't throw a bug? Then is it fine then, I guess? Or?
If you don't finish your array with objects with a nil, it's not going to. The compiler is not going to tell you. You should see it pretty quickly when you run it, though, because yeah, you're going to be adding basically bogus memory into that array, and that's true. So there's a chance that there's a if it doesn't crash for you, you're lucky. But it may not, because it depends on the structure of your stack. So, does that help? Yeah. Yeah. If you're using array with objects, plural, make sure you end it with nil, or else yeah, you'll have some problems. Yeah.
So, what if one of the internal elements of the array is nil?
The question is, what if one of the internal objects in the array is nil, and you can't do that? There's an array only holds objects, and nil is not an object. You can have is NS null an object?
NS null null.
NS null null. Oh, right. So if you call, open square brace NS null null and close square brace, that's actually a special kind of object that represents null. And you can put that in your array, but you can't put nil inside your array. So, yeah. Any other questions? Assignment questions? No. Yeah.
You said arrays are nil terminated. How does that have to do with what you just said? Do we have to put in that null object, or
or?
No. So I don't want to confuse them. Arrays themselves are not nil terminated. Arrays are just blocks of, groups of objects that are maintained for you. You don't need to worry about what it looks like under the hood. Where the nil is important is where you're calling the array with objects method. You use nil at the end, so you're going to put, array with objects, object 1, comma, object 2, comma, object 3, comma, nil. And the nil is just to say, hey, I'm done. I'm done with this method call. There's nothing else I'm going to provide to you. The null doesn't go into the array. Yeah?
Wait, do we need to put the nil in, though, if we specify the number of objects that we're going to put in there?
Is there?
I didn't get an error with that, though.
Right, so the question is, if you specify the number of objects, do you need to call it with nil? Is there an object that, is there an array method that says?
Oh, I think he means like if you allocate it with capacity.
Oh, yeah, right. If you call, array with capacity and then add the objects, you still need to. You can add the objects one by one. Maybe, is that what you're doing?
Yeah, that's what I did.
Okay, so what you're doing is you're saying init with capacity, which is creating an array that's big enough to hold this many objects. And then one by one you're saying, add object, add object. That's fine. Yeah, that's fine.
Yeah, I just didn't put nil in and it works.
Yeah, no, that's fine. You don't need nil for that because it knows you're only going to pass one object. On the other hand, there's another method called add objects, plural, which does take more than one object. And then you need nil for that. But you're not using it, so we're good.
Okay, cool.
Yeah. Yeah, anything else? Okay. There's another example of that, which is NS Dictionary. If you say dictionary with objects and keys, it'll expect an even number of arguments of objects followed by string values in that order: object string, object string, object string, and it'll keep reading until you put a nil there. So there's another example of that. All right, so let me do a quick example here. Actually, we're pretty close to the end. This will be fast. All right, so I'm opening up Xcode here. I'm just going to create a little project that will kind of illustrate, I think it'll illustrate auto release and kind of the way that things happen here. And I'm just going to do it through logging. So let's create a window-based application, and we're going to call it retain count test. Okay, so just to be able to trigger this, I'm going to add a button to my nib that will do what I need. So let's add an action. You should all be familiar with this by now. I'm going to add this IB action, which is run my test, and I'm going to call it from my nib. Let's make this full screen. All right, so let's go to our nib. I'm just going to have a button call this function, and we're going to run a little memory test when that happens. So here, let's pull in a button. And I'm going to assign the action of that button to my run my test. And let's see, what should we do here? Let's create our run my test. And what should we do? Let's log our retain counts as we go through, and we're just going to run it and check what they are. So I'm going to create a NS string, this string equals, let's call mutable string, string with string hello. Okay, so we just created a string, and let's log the retain count on that, just to prove that what I'm telling you today is not complete lies. String retain count is %d because it's an integer. I'm going to say this string retain count. And now I'm going to retain this string, and let's log the results of that. Now I'm going to release this string. You can see this is a very complex shippable iPhone application. Release. The retain count is whatever that comes back. And what's going to happen if I do it again?
Crash.
It'll crash. Well, will it crash? So let's see. I have an auto-released string here, right? What's the retain count going to be? It's going to be 1, right? If I call retain on it, the retain count is going to be 2. If I call release on this, the retain count is going to be 1 again. And if I try to call release again, it's going to take the retain count to 0. So it's actually not going to crash yet. What it's going to do is it's going to crash. If I call release again, it'll crash when it goes to try and auto-release it. So, you know, because we've auto-released here and we've retained and released, we're balanced. We don't need to do anything else. So let's just run and just see that we're not crazy.
It frees the pool when you close the app, doesn't it?
It frees the pool, actually, in this case. Well, so let's look at the results. So 1, 2, 1, right, from the auto-release, then the retain, then the release. But the pool gets freed as soon as I unclick that button, actually, or as soon as it finished calling this method. That's when the pool gets released.
So it would crash.
Yeah, yeah. So, and you know, let's just do it for fun. Don't try this at home. Let's do this string release, and we're going to say nslog, hey, I'm still running. Running, I can't type. And if we get this far, we haven't crashed yet, but we should see a crash pretty soon after that. So far so good. We haven't called anything yet. When I click the button, there, it crashed. So we see string retain count is 1. String retain count goes up to 2 because I retained. String retain count goes down to 1 because I released. String retain count goes to 0 because I released. We're still running. And then when the auto-release pool gets drained, we go to -1. Actually, the bad memory was called to try and release, and we crashed. So, yep, that's it. Takeaway from today, balance your retain release. Use auto-release when you can, especially if you're returning values from methods, and have fun with properties.
For more, please visit us at stanford.edu.